Hello everyone, here is a question based on Gibbs free energy. For the reaction at 298 K, 2A plus B giving C, delta H is 400 kilojoules per mole and then delta S value is 0.2 kilojoules per Kelvin per mole. Determine the temperature at which the reaction would be spontaneous. We know from Gibbs Helmholtz equation that delta G is equal to delta H minus T delta S. Here they are not asking us to calculate delta G, but when delta G will be negative, because the reaction would be spontaneous only when delta G is negative. If delta G has to be negative, then delta H has to be less than T delta S, or T delta S should be greater than delta H. So at what temperature we can write a equation so that we can get delta G negative. So therefore let's put it this way: delta G is equal to 400 minus T value is we need to find out, and then 0.2 kilojoules per Kelvin per mole. The temperature is in Kelvin, so therefore Kelvin per Kelvin will cancel. This is also in kilojoules per mole. Think about it. How we can get 400? Because if we get 400, then delta G becomes 0, isn't it? What term we should put here so that we can get 400 minus 400? So if we put 2000 times 0.2, or if you want to write it this way, let's say if you still want to make it easier, if we put 2000 times 2 times 10 to the power minus 1, then what will happen? 1010 we can cancel, so this will also become 400, because 200 times 2 is 400, we have 400 here. Then it would become, delta G would become 0, that is at equilibrium. So this means the temperature has to be greater than 2000 Kelvin. Only then the delta G becomes negative. Therefore the correct answer is temperature has to be greater than 2000 Kelvin.